Welcome back, class. Today we're going to be talking about our second lesson in 70-741, installing and configuring DNS servers. We're going to be covering a lot of topics in this, but like everything else we've talked about, it all goes back to planning. Spend your time, map it out, draw it out, think it out, so that when it comes time to implement a network, a server, a service, you do it once, you do it right, and you put it online. So we're going to be covering all these various topics, but what is DNS? DNS is domain name system. The servers that run DNS we also call name servers. For us to be able to do anything on our networks or on the internet, we need to have DNS because everything that we work with is mapped to an IP address. There has to be an association between that IP address and what we would call the friendly name of that resource. Think of it as being a phone book. You may know your friend's first name and last name, but you don't know their phone number. You open up the phone book, you look down the listing, and there is their phone number. Now you can contact them. DNS works in a similar way. From the enterprise perspective, we run internal DNS that allows us to map fully qualified domain names to the host names within our network. For example, they show computer1.sales.microsoft.com. That is a fully qualified domain name, an FQDN. Computer 1 is the host name. It resides or is a member of the sales domain, which is located in the Microsoft second level domain, which is located in the .com domain. We're going to talk about these second level and top level domains here in just a moment. But put all together, it produces a fully qualified domain name. Top level domain are the .coms, the .edu, the .biz, the .us, the .gov, the .uk. This is what is at the very top level of our DNS hierarchy. Second level domains are what identify the individual or organization, such as Microsoft.com, Google.com, Bing.com, BrowardSchools.com. And then the host is that specific computer or device within that domain. For the example they previously gave, computer1.sales.microsoft.com. Every time a user needs to look something up, needs to contact a server, wants to contact another host, another device, it needs to be able to resolve that to an IP address. So if it knows about that, that gets added to a cache on that client. Those IP addresses and names are cached, so it doesn't have to look it up every single time. It doesn't have to contact the DNS server every time to find something. However, if the name is not in the cache, the client contacts its first DNS server. If that DNS server is available, but it doesn't know the address, the client doesn't ask another DNS server, it waits. The DNS server, however, attempts to contact other DNS servers to resolve that IP address. It then, in turn, responds back to the client. The client now knows how to get access to the resource, and it adds that information to its own internal cache, as well as that information now being also cached on the DNS server. Many times organizations will use what's called split DNS, internal and external DNS. We have to keep these separate because obviously you don't want to publicize your internal resources to an external DNS. And at the same time, internally, you want to be able to get access to all those records. So when we install DNS, for example, In our lab setup, when we installed Active Directory, it automatically installed DNS for us. However, you can install separate DNS servers and have them integrate with other services such as Wins, DHCP, Active Directory, so that if a new IP address is handed out through DHCP, it can update your DNS. Without DNS, we'd be very limited on what we could do. We would have to walk around and modify what's called a host file on every one of our devices with an entry line for every single device on your network. If a resource changes, you would have to go and modify that host name on every single one of those devices. Not very efficient, very time consuming. DNS saves us a lot of time. When we go about deploying DNS, there's 5 basic steps. We install DNS on one or more servers. We configure that DNS. We create our forward and reverse lookup zones. We add any necessary resource records to those zones. And we configure our clients to use those DNS servers. So, as we talked about, before we can install DNS, we have to plan. How do we want to use it? What are the requirements? For the most part, remember that DNS servers need to have the capability to support thousands of requests per minute. But at most, you might only need a 1.4 gigabyte 64-bit processor, half a gig of RAM, 32 gigabytes of free space. It can operate very efficiently. This ends the first portion of our DNS lesson 2.